Bismillahirrahmanirrahim. Today I am going to discuss chemical vapor deposition. In previous videos, I discussed few methods of nanoparticle formation. For example, I discussed hydrothermal technique, sol gel method, and in chemical vapor deposition, we deposit inorganic material on any substrate, for example, ceramic surface or glass surface or on any metallic surface. So what happened in this process, this method is used to deposit inorganic material on substrate. Substrate may be a ceramic, glass or a metallic substance. So few of its advantages are nano coatings are also done by this method. Pure metal is deposited and impurities or byproducts can easily be removed. The most important advantage of this method is that it gives 100% yield. So as this process takes place at high temperature, then thermostable materials are obtained. Anti-corrosive coatings are done by this technique, and this is one of the economic method, and this method is also applicable in microelectronic industry as well. So what is the instrumentation and procedure of this method? First of all, let's see the instrument. There are two most important parts of this instrument. One is material evaporator, other is a reactor or main reaction chamber, and both of these are supplied with feeding lines. So if the sample which we are going to be deposit on the surface is a gas, if the material is in gaseous form, then that is directly introduced into the reaction chamber. But if the material is in the form of liquid or solid, then this material is taken in material evaporator. So we heat the material, vapors are formed, and these vapors are carried to the chamber with the help of carrier gas. So this carrier gas take this precursor substance into the reaction chamber. The other gases which are required to be react with this precursor substances are introduced through the different feeding line. So both of the gases and this precursor substances, these are get attached to the substrate. So if we see the steps or procedure of this method, then the first step is precursor substance is transported to the reaction chamber using a carrier gas. As I told, this precursor substance is taken to the reaction chamber with the help of this carrier gas. This gas may be any inert gas. For example, in this process I take argon. So second step, reactive gas. Other reactive gas is introduced from the other feeding line. For example, we take hydrogen. This is introduced through another feeding line into the reaction chamber. So now hydrogen and, for example, precursor substances magnesium chloride, both are now present in the chamber. In third step, both the substances get attached to the heated surface of the substrate. As the instrumentation shows that these walls are provided with heaters. So we called it as hot walled CVD instrument. In cold wall CVD instrument, we do not use heaters. Instead, we use heating coil which are attached to the substrate directly. So in this method, we are using heaters. So these provide homogeneous heat to the substances present in the reaction chamber. So in third step, both the reactants get attached to this heated surface. Here chemical reaction takes place and the required material is deposited. For example, reaction takes place between magnesium chloride and hydrogen. Magnesium is deposited while the hydrogen chloride is separated from the surface. So if we look at this substrate, all the blue material or magnesium is deposited on substrate surface and the hydrogen chloride as a byproduct is separated. So how this byproduct is removed from this chamber? We remove it by the mass flow of the carrier gas. We can use same gas or different gas to remove this byproduct by using exhaust pump. So in this method we obtain 100% pure material as a nano coating on the substrate surface. So this is all about chemical vapor deposition method. Thank you very much.